Hey everyone, so I'm Labrina Loving. I work at Microsoft, and today we're going to talk all about API communications with microservices. And we're going to do that using a couple of services in Azure, specifically API Management and Azure Functions. So, quick agenda for today. We're just going to do a quick microservices refresher. I know everyone that's been listening to the conference now is probably an expert, but thought it'd be good we do a quick refresher. Where we'll kind of talk about some of the problems with microservices, and then we'll focus on why serverless microservices is a good idea. We'll talk through our two services we're going to focus on, API management and Azure Functions. And then we'll do the thing that I'm sure you all came for, which is the demo, and do some resources and wrap up. So I know we've been talking a lot about microservices throughout the day, but just to level set, microservices are independent modules that are very small. They're small enough to take very single actions. So you really want to think about when you're thinking about microservices, building a single focus, a single concern. They can be independently built, they can be monitored, refreshed, all independently. So you could have a team, a distributed team that's working on various microservices in different languages, using different tool sets, whatever works best for them. So microservices have autonomous scalability. That means that they can scale at different ways depending on the needs. So imagine that I have a couple of services, one that does a get very often, and then another one that does updates and delete, and a separate one that does delete. Imagine if I had those three services. The get service microservice probably will get called the most. So it can scale up very quickly and then scale down, but our delete and our update might get called less frequently and less have less calls. So we can scale that as well. Isolating points of failure. So each of the services can be managed independently. So finding points of failure is a little bit easier in the microservice architecture because each service will return their own set of failures, and you'll be able to see very quickly where failures lie. And as I kind of alluded to, what I really like about microservices is that often in very large teams, you have different developers with different skill sets. You might be bringing in legacy code that's in different technologies and languages. And with the microservices architecture, you can, all of these tools and technologies can coexist within teams. And then that brings about the ability to get to market faster. So let's talk about the problem with microservices. So um, in a microservice architecture, each microservice exposes a set of very fine-grained endpoints. So if you look at my um, graph to the left or visual to the left, I've got these individual microservices that each have their own independent endpoint. And then they're being called by a client app in the front end. Mobile, it could be a mobile, it could be a web app, it could be anything. Um, the challenge here is that oftentimes each of this mobile app needs to call various microservices. It also might need to call microservices that are dependent on one another. So how do we handle chattiness across our applications? And then also, how do we handle things like cross-cutting concerns, like security or SSL offloading? And this approach with our kind of direct client to microservice communication, each of these microservices are handled independently, and it sort of brings about a lot more chattiness. The other approach, which is a lot more reasonable, is doing what's called an API gateway pattern. So in this way, we actually have a single entry point that's controlling communication to our various microservices, and acts as a facade. That way we can mock out different services as they become available. We can also do things like do cross-cutting concerns. So within my API gateway, I could have universal policies or universal tools for things like logging, for things like security concerns, all within the same kind of single pane. And that handles a lot of our kind of communication headaches. In a sense, this API management or API gateway acts as a facade or a reverse proxy that routes requests from the client application to the backend services. Okay. So we're kind of combining two really nebulous terms, serverless and microservices, together. So serverless microservices, let's kind of break it down. So serverless is can be a confusing term. It can be read in that most people, when they think about it, they think, oh, hey, there's no servers. But indeed, there are servers, just like in cloud, there are tons of servers. So serverless actually means not that there aren't any servers, but it actually means that we focus less on servers and more just on the functionality. So it allows developers to actually focus more on just building functionality and less on worrying about things like compute. It basically abstracts away the servers, so you don't need to worry about compute or scaling or sizing or things like that when you're building out your solutions. And in addition, when we talk about serverless, we often talk about what's called event-driven. So building things in an event-driven approach gives us the ability to migrate some problems from very traditional approaches. It allows us to scale compute resources. It allows us to remove operations dependency. So oftentimes when deploying a microservice-based solution, there's usually a strong dependency between what our operations teams do for allocating our infrastructure resources and execution and incremental changes. So taking a serverless approach gives us the opportunity to use fully managed services and removes the necessity for all the kind of underlying infrastructure that's managed by your platform that would typically happen. And then the last thing that we kind of benefit from with serverless microservices is that managing services and communication and integrations are really common issues or problems in a distributed application. So how do we manage and monitor communications across a distributed application? So since each of these services kind of are performing a specific action, according to this single responsibility principle, more often than not, services will need to communicate with each other to achieve a goal. So we have this challenge of how do we make sure we can monitor each of those services together. So with an event-driven approach, um, with services discovery, you have a centralized and unified way of communicating with services and events. You can do things like publish and subscribe to events, as well as having things like triggers. So instead of something waiting, service waiting, it actually can be triggered based on a number of actions that could happen. And we'll talk about some of those services that help aid in that in a little bit. Okay, so the first main service that we're going to talk about that we're going to utilize in our solution is API management. So API management really helps organize the publishing of APIs, both within an organization, or if you're publishing a set of APIs externally to make them publicly available, it also aids in that. So API management provides a set of core competencies that ensure that you have a very single, centralized manner for managing APIs. So you can do things like have a secure infrastructure. So you have gaining access, preventing of denial of service attacks, um, doing thing by using things like reducing throttling, or you can set up securities in place like JWT token for validation. It also, as I mentioned before, supports having public-facing APIs. So you could have a universal pane for all of your public-facing APIs. You can have universal policies that support things like security. You can also do things where you can, as I mentioned before, support throttling. And then in enterprise organizations, you can use API management as a way to support having a centralized location for all of your APIs to make them easily discoverable for your organization. So, how many times, and this happens even internally within Microsoft, we have so many services, we have so many APIs that are sort of all over the place and they're not easily discoverable. To the organization, and API management can be a place where everyone publishes their APIs. They could easily be protected, and then also they could easily be versioned as well. So as new versions of your API roll out, you can actually have ways to version it, determine which version is available. You can support multiple versions of your API as well. Okay, so Azure Functions is really kind of one of our main services for building out serverless um, applications. Azure Functions allow you to run just small pieces of code in the language of your choice. So you can use C Sharp, Java, JavaScript, Python, or PowerShell, or you can do both. So I've been on development teams where we had, for various reasons, we had functions that were built in C Sharp, and then we had a couple of functions for other reasons that needed to be built in JavaScript, and they needed to coexist. So we definitely use a microservices approach and architecture for dealing with that. Um, the thing with functions is that they are event-based and event triggered. So functions are triggered in a number of different ways. So they can be triggered by an HTTP request, which is primarily what we'll show in microservices architecture in a bit. They can be triggered in a schedule. They can be triggered based on things like Cosmos DB updates or changes, blob storage, queues, um, ones do I have? Event Grid, Event Hub, Service Bus queues, and even Service Bus topics. So one of the things that I also really like about functions is that typically functions um, uh, are designed to be stateless, meaning that they're designed to be called one time. They perform a small bit of code, and then they spin up, and then they execute the code, and then they spin down. What you can also do is you can actually use stateful Azure functions, which actually durable functions that actually can maintain state. So if you have um, a, a long running event pipeline that needs to maintain state and you want to be able to execute several tasks as that state changes, durable functions are a good choice for that. And we'll talk a little bit about that in the architecture that I'll show. In addition, Azure Functions provide integrated security, so you can secure your functions using Azure AD. And then there's tons of integration into other services within the cloud native ecosystem. Okay, so let's talk about a demo. One of the things that I have just started doing recently is I've gotten into podcasting, and I had been looking for a good podcast platform, and unfortunately, I really haven't found one. I mean, I found kind of parts and pieces, but I've never found a really good one that does all the things I really wanted. So I thought it'd be cool to actually start building out my own podcast using microservices and functions and API management. So let's take a look at the architecture that we're building out. And this is somewhat based on my own desires, but also very loosely based on some work that I've done at a couple of customers as well. So we actually have a podcast site that is running in app services that is communicating and authenticating users using Azure Active Directory B2C. As we kind of talked about with our API gateway pattern, we're using API management as that single entry point for our web application to enter and call whatever services, whatever microservices that it needs. Then I've got several microservices that are hosted. And one of the things I'm doing is hosting it within a VNet to ensure a virtual network to ensure that to be able to ensure that only certain services are able to communicate and I have true networking. Then I've got a couple of Azure functions that are my microservices. So I've got an episodes API, I've got a host API, and I've got a guest API. Then I've got some durable functions in the back end that are maintaining state as I need to publish an episode. So you can imagine if once you record an episode, that episode has to get uploaded. And then there's several processing steps that happen. We're doing things like translations and other things. So I'm using what's called a durable function here to publish that episode and get it ready to be distributed to our different podcast outlets like Spotify or Apple Podcasts. Then I've got another durable function over here that will do scheduling for guests. So then I've got some cross-cutting concerns at the bottom using Azure Key Vault for any secret management, and then App Insights for any monitoring that I need to do across all of these different APIs, which is really key here because as we were talking about, I've got a lot of services that are kind of working together, and I want to be able to monitor and make sure and have observability in all of those services. Okay. So let's take a look at just at a high level. I'm going to walk you through my Azure function that I have set up. I'll walk you through one. A lot of them, the other ones work very similarly, but I thought I would just kind of walk you through setting up the Azure function, how it would work, and then how we would deploy it. And then I'll show how it actually gets imported into API management so that it could be made available for our web application. So I've got an Azure function here, my episode function. I've got a function called episodes get. And this basically is just retrieving all of the episodes from our, I forgot to mention, our data store for this example is Cosmos DB. So it's retrieving all of our episodes from Cosmos DB. I've got a service, so I've got a model defined called episode. Let's go here. Yeah, so I've got a model defined called episode. It's just defining things like the name, the title, publish date, any show notes. Then I've got a service that's running in the back. That's an interface. Let's go to the concrete. That basically so I've got an interface defined for a service that defines all of the methods that I want to do, like get ID, and then things like translate. And then if I look at my concrete class for episode service, it's I've got a data service that's defined that basically is handling all the communication back to Cosmos DB. So if I take a look at that data service, here's my Cosmos DB service. That here's an example of the get. It's just a querying and getting my collection type. So I'll just do a quick debug just so you can see what happens when we debug our services in Azure Functions. And you can see the core tools are starting. And you can see it's defined a couple of services. So my get by ID, and then I've got an upsert one that I've defined. And then you can see I'm debugging locally. It's defined this on localhost port 7071. So I could try to right now run this. So I had some breakpoints set up. We'll get rid of those. And then should be coming back soon with my set of episodes. Cosmos DB might be gone. Let's see. Anyway, I think my Cosmos DB might be dead. Oh, also I'm missing that breakpoint. Why are we not running? Anyway. Oh, so here. So here's like just my set of episodes. So here's my set of episodes or that I've returned just using my API. So what I'll do next is just show how we would deploy, how we might deploy this. Oh. Well, so I am actually in my Azure portal. I've actually stood up already some app services. Normally what I would do is actually have use continuous integration and continuous deployment with something like Azure DevOps or GitHub Actions to deploy my code from Azure, from my source control into Azure. So here's my podcast episodes, Azure Function. You can actually see here's my 3 functions that I've got defined, and they're here. So I could do things like code and I could test right in here. I could do things like monitor as well. So you could see some of the results that I've got. The important key that I wanted to show now, so now that I have my Azure Functions deployed, I could then actually now use API management, as I said, as that single pane to single point of entry for all of my functions. So if I go into APIs, I've already imported my podcast episodes. So you could see here, I've got these already defined. I could go here and define policies, and we'll walk through creating a sample policy in a bit. I can do things like test it. I could add revisions. So if as my functions get revised, I could actually go in and make changes and maintain those revisions right within API management. The other thing that I really like about API management is that one of the techniques that we use sometimes is that you can actually create mock APIs. So I could mock, so let's say my episodes set of functions are available, but maybe my kind of bigger API durable function for translating doing speech to text translation of my podcast isn't ready because that's going to take a little bit more work. So I could go in here and create an API and then also mock that out while I'm still developing, which is incredibly powerful because then that kind of allows the rest of the development team to keep working while we're kind of working in the back end on that one microservice. So if I wanted to add the other set of APIs, when I click Add New API, I'm presented with different ways I can import an API. So I can import APIs from OpenAPI. I can do import an API from Logic App or App Services. And then I can also, as I'm going to do from a function app. So then I can click and look for my function apps. I've got quite a bit out there. So here's my podcast host. So I'm going to import that one. And then have that ready. I didn't deploy that one yet. Okay. So cool. And then, as we talked about before, I'll switch back to I'll switch back to the PowerPoint. Okay. So, as I was mentioning before, one of the things that we can do with having kind of our single point of entry is that we can have authentication run across the entire our entire set of policy, our entire set of microservices, and so therefore I can offload that work from each individual development team that's developing microservices and move that work just at the API management, API gateway layer. So here's an example of just an authentication policy that I set up that, and you can set up through API management, that basically valid checks for a validation token based on OpenID config. I can pass in that and it will validate that, and it will validate that across all of my microservices. The opposite point, or the other option that I would have to do, is that then I would have to use something in my Azure function to authenticate each function individually, or I can do things like add what's called a filter attribute that would filter each call at the function layer. But I prefer this if possible because it's just a lot cleaner and it kind of gets our developers out of that way. Yeah, so good. Okay. So just to wrap up, there are some really great resources to getting started with Azure Functions and with API management. Um, there are some really good examples that I show that are based on the example that I showed today. There, one is the serverless microservice reference architecture, and another one is an example that my previous team built for a customer as well. Okay, so I think that's all of the content that I have. I don't know if there are any questions or anything. I'm happy to take those.
I was going to say we are actually out of time for questions.
Oh, okay.
So since we're right on, so thank you so much, Labrina, for taking the time. If you want to check out Twitter, I'm sure people are going to be asking those questions as they come along. So we are trying to get here our next speaker, Elton Stoneman, who's going to talk about evolving monoliths with .NET. So yeah, thank you so much, Labrina, for taking the time to talk to us. And everybody will be right back with more .NET Conf focus on microservices.